Dear students, welcome and thank you for tuning in to this video with me, Dr. Al-Zube. We are still talking about the kinematics of a particle as part of the statics and dynamics course. So in the previous video, we talked about position and displacement and total displacement. In this video, we're going to talk about velocities. So velocity is a measure of the rate of change in the position of a particle, and it's a vector quantity. So it means that it has both magnitude and direction. And in kinematics, it's important to identify your reference point, as we mentioned in the previous videos, and you need to identify if your displacement is going to the right or to the left of that reference point, because we are talking about rectilinear motion. So if it's to the right, your sense is positive, and it's to the left, or if it's to the left, your sense is negative. And since time is always positive, velocity will follow the same thing. So if you have a positive velocity, it means that you're moving to the right, and if you have a negative velocity, it means you're moving to the left. So it's very important to identify your reference point that you're starting from. The magnitude of the velocity is called speed, and it has a unit of meters per second or feet per second, depending on which unit system you are using. So this is velocity in general. We would like to identify a number of quantities that we will be measuring. So the first one is the average velocity of a particle, and during a time interval delta t. So the average velocity is actually if the particle moves through a displacement delta s during a time interval delta t, the average velocity is given by delta s over delta t, and if it's a vector, it's delta r over delta t. So that's the average velocity actually that we want to be able to identify and to calculate. If you are making smaller and smaller values of delta t, the magnitude of delta r or delta s actually becomes very smaller and smaller, and that is where we consequently get instantaneous velocity of the vector defined as v, which is dr over dt. And that's very important because we're going to have the position as a function of time, and in order to find the instantaneous velocity, you need to derive the position, and then you can find the velocity at a specific point of time. Now, speed is actually the magnitude of the velocity, instantaneous velocity, which is ds over dt. So velocity, average velocities, and then instantaneous velocity and speeds. We are going to focus a lot on instantaneous velocities and some work on the average velocities, but I will show you how to do this in examples as we move forward into the lecture. There's another quantity that's very important in kinematics and dynamics in general, which is called the average speed. And speed is a scalar quantity, and so average speed is always a positive quantity because it is related to the total distance traveled, which is st. And if you recall, we identified that from in the previous video. So the average speed is st divided by the time traveled, delta the time or the elapsed time. So that is, and you keep in mind that it is written as v speed, and in parentheses then you have the average avg notion. So those are the most important quantities that we need to pay attention to in analyzing a particle moving in a straight line. So it's velocity, average velocity, instantaneous velocity, speed, as well as average speed. And we're going to solve a lot of problems in identifying these quantities. Thank you for watching. Until the next video. Bye.